Hello, this is my video explaining glycolysis. So the main goal of glycolysis is to rebuild ATP using energy release from breaking down hydrogen bonds in glucose molecules. Glycolysis is the predominant system in that duration of 10 seconds to 2 to 3 minutes of intense exercise after ATP-PC. Glycolysis is an anaerobic process, and it's also extremely inefficient considering that 70% of the energy produced is released as heat. There are two phases to glycolysis. The first is energy investment and the second is energy generation. So step 1 of glycolysis involves trapping glucose inside the cell. So you can start glycolysis one of two ways. You can either start it with glucose, which is going to require investing 2 ATP molecules, or you can start with glycogen, which is only going to require investing 1 ATP molecule, which will result in a higher net gain of ATP in the end. The rate limiting enzyme of glycolysis is PFK, phosphofructokinase. And then there's stimulants and inhibitors for PFK to let it know whether it's ready to go through glycolysis or whether it's not ready to go through glycolysis. So the stimulant of PFK, I'm just going to shorten it for now, is any ADPs or free-floating phosphates, because those indicate that energy is being expended and therefore it needs to be replaced. An inhibitor of PFK is going to be having a lot of ATP or phosphocreatine inside the cell, because that indicates that the cell is not using that energy if it's still got those energy molecules inside of it. So after we get to PFK, we enter into the second phase of glycolysis known as the energy generation phase, which out of this phase, 2 NADH molecules are produced from 2 NAD plus molecules, adding a hydrogen, and 4 ATP are produced. Here's a side note, glycolysis cannot occur if NAD plus runs out. If there's no more NAD+, pyruvate turns into lactate to pick up the extra hydrogens that couldn't be added to the NADH. So, like I mentioned earlier, that if you were to start with glucose, you would invest 2 ATP, and if you were to start with glycogen, you would only need to invest 1. Well, since this process is producing 4 ATP total, your net gain of ATP if you use glucose will only be 2, while your net gain behind glycogen will be 3 ATP, which would make it barely more efficient. So the end product of glycolysis is not ATP, it's actually pyruvate, and you'll end up with 2 pyruvates at the end of this. And the pyruvate can do one of 2 things, depending on whether there's oxygen present. If there is oxygen present, pyruvate will be sent to the mitochondria to break down into acetyl-CoA, which is also known as slow glycolysis. And if there's no oxygen available, pyruvate will accept the hydrogens from NAD plus or NADH and form lactate, which is also known as fast glycolysis.